problem. So what? Go ahead.
Question number 3.
Oh, it was our third example. We did 2 yesterday. Sorry, it's just there are lots of examples. Multiply the formula, huh?
No, if the 3 was in it, it would.
Oh, if the 3 was in it, yeah, it would be like a constant multiple.
Yeah.
But no, sorry, this is the third problem. Here we go, the integral. So what other rules do we have?
Just you need power rule.
Power rule, basically. We have polynomials. There's no division, though, so then Sean, I'm going to use him just because I think he's already grappled with this a little bit this morning. How can I rewrite this to where there is no division? That's the goal, rewrite.
There's 2 ways. There's 2 ways you can do this. You can
Yeah.
either split up the fraction, or you can take that x squared and put it on top by making the exponent negative, which is a lot easier because then that leads to multiplication. And then that really helps us by simplifying down the top in a faster way.
Okay, so then you're thinking make it x to the negative 2?
And then just writing in the original, what's up top, and then distribute in that x to the negative 2, and you're hey, that's really nice because now I have a 3.
Remind me real quick, what's the property that lets me do like bases?
Like bases.
With
When
multiplication.
you
What do I
multiply,
do with
you
the
add
exponent?
exponents.
You add the
Good.
exponents.
And so negative 2 plus 2 would just be 0, which is why Charlotte, when I asked what this simplifies to, was like 3 minus y. Because 3x squared over x squared, you can think of it just visually. If I was to divide both by x squared, it's like a distribution of that division. The x squareds cancel, only 3 remains, or x to the 0, which is 1. Only 3 remains. And then minus.
Minus 2 to the times x to the negative. Yeah, please. So now we can integrate by using the constant rule and the new power rule that we have.
And technically subtraction, the difference rule, saying we can do it piece by piece. Can I show one other way, just because this is a good way. Some of you aren't so hot at exponents, so it's a little bit confusing, but hopefully it makes sense in that there was division by x squared, which means I can make it multiplication by x to the negative 2. Another way of going about it is some trick. Well, let's not do the trick first. Another way of going about it would be to see this as 3x squared minus 2 divided by x squared. And when you divide by something, you multiply by its. So you could think of this instead of x to the negative 2, if it helps you visually. You could think of it as times 1 over x squared and still do that distribution, still do the multiplication. It means the same thing. X to the negative 2 is 1 over x squared. Some of you see this a little bit better as far as when you distribute, the x squareds cancel, just 3. What would be different here is that you would just get 3, but then you'd have 2 over x squared. If you guys visually like the blue better, how could you go from here to what Sean has ready for the power rule? What would you do to this? Yeah, bring it up x to the negative 2. So you don't have to start with x to the negative 2. You could start with 1 over x squared, bring it in, then go to the negative exponent. That's one way. And the other way, Charlotte, correct me if I'm wrong. I'm not sure if you did this whole thing in your head, and I'm not sure if you did this whole thing in your head. I think you just thought divide. Yeah. So the other way is that you can think of a shortcut when you're dividing by some sort of expression, which this one is x squared. And there's that subtraction. You can do distribution of the division, which is like writing it like this. And in Algebra 1, when I taught it, I would call it the heart method, because you would divide 3x squared by x squared, which is just 3,
like a heart.
minus 2 over x squared. So it looks like a heart when there's 2 terms. If there's 3 terms, it's a weird heart. But that does help, because if you were ever to have, let me show you an impossible, I should do it in the notes for anybody who's absent today. With the sickness going around, there might be a few. But I'll delete the page as soon as I do it. Here's an impossible problem that you would not yet know how to do. Don't write it down, just look at it. Why is this one going to be impossible?
Heart method doesn't simplify it.
You can't. If I was to do a heart method, that's all I got. Because I have to divide the 3 by this guy, and you can't do an upside down heart. It's no longer a heart. So this is not a legal. It doesn't even look right, right? Like, no, that doesn't work. So Heart method only works with an upright heart, but the heart could have multiple pieces to it. But it has to have one denominator that you're dividing. So we couldn't split this up. Even if you tried Schonstrick, here's the struggle. Schonstrick would be...
So what's that, boy?
Distribute! No, it's a power! It's not a multiplication! You can't distribute the negative one.
Is there
What do you do? What if we use my trick of multiplying by the reciprocal? Does that help?
No, because it goes back to the original.
Now, if you thought of your derivative rules, if you thought there was this one weird derivative rule that had 1 over u squared plus 1
Sounds like tangent.
arctangent, maybe you could go backwards. But without thinking of that specific derivative rule, which is not our purpose or point in these basic derivative rules today, you wouldn't be able to solve it. Let's go back, so we have not finished the problem yet. I apologize. How do we finish now that this one can be rewritten as powers?
We got this. We got this. Let's rule it up.
Integral of 3. Pause. Look at your table. Someone in this class, actually multiple people, could tell me the answer right away, but that's not the point. When you figure it out, look at the table. 3 is a constant, right? Where do you see the integral of a constant? Integral of c, or integral of k? Kx plus c. So the integral of 3 is going to be 3x. Pause. Does that make sense? Derivative of 3x is 3? Good. Why am I not writing the c? Well, because this is one big antiderivative. So I'm going to put a plus c at the end. This is going to have a plus c1, this is going to have a plus c2. I just say the whole thing has a plus c. Think if you had a plus 2 and a plus 3, wouldn't you put them together?
Yeah.
So we just put one big old plus c at the end. The difference rule says do it piece by piece. So we integrated the 3, now minus. It's time to integrate the 2x to the negative 2. If you need to, you could write that out as 2 times the integral of x to the negative 2 dx. You could do that. We could save the plus c until we actually solve that integral, then there will be a plus c. But if you can get to where you can look at this and say, hey, just like derivatives, the 2's sticking around. And he is. The 2's sticking around. And in your rules, if you look at your table, the k, with k times f of x, the k can come out. He sticks around. So then we're just looking at x to the negative 2 as the power rule. If you wouldn't be able to tell me the power rule for integration right now, look at the table. The integral of x to the n is x to the n plus 1. So n is negative 2 plus 1. I'm just writing it out so you can see the rule. Divided by, or times 1 over n plus 1. And then I need my plus c, because that's the end of my antiderivative. Now, of course, we want it to look nicer, so we're not going to stop there. But we would have 3x minus 2 times x to the negative 1 all over negative 1 plus c. Can you guys see how it's the same thing as 3x plus 2 over x plus c? Because x to the negative 1, negative exponent says pop it down, the negative, well, negative times, or divided by, I should say, a negative is a positive. The x is down below, the plus c is there.
So,
And, oh no, go ahead, Sarah. No.
do we have to like clean up our answer? Or do we do
Think of like derivatives.
No.
Think of derivatives, how we had to think about making it match. Similar idea of derivatives. So if we rewrite it and then derive it, technically you could stop there, but a multiple choice answer will never have that. Does that make sense? And in the back of the book, you won't be able to check it unless you keep going. But speaking of that, making it match could, if this was a multiple choice question, you were trying to make it a little tricky, so it wasn't super obvious on kids that are much better than you guys right now at integrals, because we're going to keep doing it, you're going to get better at it. How could you make it a little trickier as far as what the answer looks like? Is there a way of changing what this looks like? Yeah. Common denominators. Yeah. You could multiply this guy by x over x and then put those two together, right? So another way of writing this is that we could have, I just want to show you, just like with differentiation, they might have rewritten it differently.
Could you do that with C?
They'll leave the C out. The only time the C gets brought in is when it's a much more difficult differential equation where it's not just a plus C.
Like plus something.
Where, remember how there were two sides to a differential? There was the dy over here, and then there was the f of x dx that we integrated both sides.
Mhm.
When this side over here is more complicated is when that c gets stuck into logarithms and square roots and all sorts of stuff.
Mhm.
But it will never happen if we just have a simple one expression integral without another side. So we'll always just be able to, if we only have an integral that we're trying to solve, it'll always be plus c on the outside. So, in your book, if you guys want to distinguish, otherwise you can just call this 4 and 5 and 6, but in your book, there's always, some of you might have gotten confused by this a few times. At the beginning of the exercises for a section, isn't there always a little quick check section? And then the exercises start? Have you guys ever gotten stuck by that and started the wrong place? No? You're amazing. Anyway, yeah, I have to. Like even when I was looking for homework questions, I'm totally in the quick check section when I'm supposed to do the exercises. So these are quick ones. Not super involved, so we're just going to pause for a second and do some basic ones before we get back into some tricky ones. I want you guys in your groups to work on these for like 3 minutes. Maybe 4. If someone's already having these rules memorized, please point your group to the rule first before you just start spouting answers. Point your group to the rule first. People in the front, your job is to turn so that you can collaborate with people in the back. Mostly that. Everyone else has. And then Tyler's turning around. You guys can work together. Then Tyler's turning around. Good, good, good.
Each piece separately, so you
Use each other in a good way. Collaborate.
So, okay.
Alright.
So there's 3 plus 1.
So it's plus cocaine.
So there's 2 pluses. Where's the 10 plus 1?
The first one
So it's 1 plus, okay, so then plus,
it's
x is 1 plus 1.
plus 1, so it's 4. And what's the other 10 plus 1?
X is to the first power. X squared, yeah, and then 5 of any constant k to
Because you can move up. Once it next to Austin, that way you like
you can do that. So then it's
Well, either way, I would go here, and then you can either turn back and listen in on Sean, or you could turn over and listen.
The x
Let's try that. Don't worry, it's so fluid. You're not gonna
What's the rule for
because it's hard for you to collaborate.
It's just the same, isn't it?
So, we're visualizing
Yeah, look at that.
we see c,
okay, so 1
but we have x,
and
that and
that's 4x to the negative 1. Oh wait, doesn't work for negative 1.
I like to think
So,
the reason why we
just
have
like the other
this
one.
fraction over here, why we have this, is because we have to think of that as simple.
This does
Oh,
work.
actually, wait, this
So we have to bring, so we have to take this n plus 1.
What was the one that you used when their x or n is negative?
That was nice and easy.
Okay.
About that.
Do you remember?
Okay, so what gets
Once
taken
For the
over?
power rule, you know, you use it when n is negative 1. What were you supposed to do instead?
Pretty sure tangents.
Now, let's move on. High five, everyone who did that. That was the first step. Okay.
Oh, Ellen absolute.
Alright. So we'll move on to this next one.
It's
Plus the negative.
We have
4
4
over
x.
x, so it's
Plus plus
Well, we can remember that x
ln
plus
is x
six.
So we have x
Tangent of x
exponent.
plus cosecant
We're
of
all
x.
just saying all that. So x to the n
I
plus
think
1.
that's right.
1 plus 1. And then so that second part, that 1
Okay,
over,
so then
so x to the third 1 and plus 1.
I'm pretty sure it's
So 1
that's the
over 1
right.
plus 1 times x to the 1 plus 1. Okay, we have one more, and that's the constant we just talked about. Can anyone tell me what the constant is? So, kx means constant times x. So you just take the side and multiply by x. Because
Well,
this is an
yes.
E to the x is obvious, so this is just e to the x. So you can do most of them.
we don't know if it's
So,
I think we know it.
Yeah, if you derive it, you derive.
Now, so all that we have,
It'd be 3 e to the
simplify.
x.
Simplify
So
the
it's
fraction,
this.
add the bottom, you guys can put them over if you would
Right.
like. Normally,
That,
separate
because make it 4
yeah,
and
it's
negative
separate, and if I don't know if I'm correct, when I go to differentiate the check, because differentiation and integration are inverses, I'm able to see zeros. It's nice and how it's supposed to be. So if we were to check,
Isn't it x can't be negative 1?
powerful,
yes.
bring the bottom down, minus by 1.
How do you do this?
4 times 1, cancel out. And then by 4 minus 1, that would be 3.
Oh, the ln one?
Bring down 2, half, 4, out, minus 1, that's 9.
I forgot my plus C's. Oh no, I'm gonna get -1 on all my test answers.
Exactly. 0.
I know, I think
X cubed plus X plus 5. So this should differentiate after this, and it does. Alright, so let's attack number 2.
Did I do like 1 or 4? You take out the 4. If you take out. Okay, so think of it, I guess you could think of it like this. 4, 5, 4. Okay. Yeah. Yeah. Okay.
How's it going?
Because if you take out the 4.
Oh.
Because you can multiply it in and then.
So, but then here,
It's pretty crazy, right?
I guess so, yeah, that's what I'm thinking. I guess. I'm not quite sure on this.
Alright guys, it should be pretty close to attempting all 3. Some of you were able to do them very fast, but if you were, you should be talking it out with your groups and making sure they're good.
That was classic.
Well,
Sorry, there were lots of emails from you guys.
hey Sam, you good?
You just do either
alright, so let's go through this. Yeah. Well, yeah, so, alright, you start with what, adding x plus,
And then
cosecant
you
times
divide by
plus.
that number, essentially.
So we have 1/4.
The second everyone's like, wow, like, family, I was like, ooh.
And then.
So let's go through it really quickly.
Yes.
Here we go. Then we have this negative cosecant. But which one do we associate when we see cosecant and cotangent next to each other? Cosecant. And remember when we're integrating, it's negative. So the negative cosecant becomes positive cosecant.
We're good.
So wait, this is just rules, right?
Yeah, it's all
Why did I like not do my hair?
Alright, can I go and expose what I haven't totally solved every single one, but make sure it makes sense?
Alright, let's take this last one, boys.
I haven't finished the last one, so let's make sure it makes sense.
But that's the spicy one, Misty.
That was nice.
Make you guys look for it a little bit.
We forgot the. We forgot the to go.
Oh, you did this?
I didn't finish the last one. I didn't finish it, I just
You have
rewrote it.
anything else?
Oh, okay, we got that.
Yeah, I just wrote the first step, sorry.
So-
Wait, whoa.
For this second one, let's identify our 2 different things that are going to happen. Alright,
Wait,
like
wait.
Mario Brown.
Why
Alright,
would it not be cosecant?
so we have.
why is it cosecant X?
Oh, because it's
Could we rewrite this in
Yeah.
any way that makes it?
No.
Yes.
Well, that's
You
pretty-
can't?
Can we rewrite this 4 over X?
Oh, I think I Did you have something double?
Wouldn't it be positive? Wouldn't it be positive?
It's
We don't know.
the integration.
That makes sense. Because it's minus, and then the rules, you'd be minus, and then that's a negative. And that makes sense, because the derivative of cosecant should be a negative cosecant. Now, this one was kind of nice, because e to the x is its own derivative, right?
Yeah.
Nice. Plus, did you guys think of rewriting 4 over x to be x to the negative 1?
Well, wasn't much need.
And then you can go ahead and add one. What happened when you tried x to the n plus 1 over n plus 1?
Well, you get 0.
X to the 0 over 0. That's bad because
The ln.
this is the one division that we don't mind. Because who has a derivative of 1 over x? ln. Look at your table. It's okay. You don't have them written in your forever, some of you. Don't have them memorized, most of you. 1 over x is the derivative of ln. Does that make sense?
Yes.
Keep your rules close, no stress. But if you did try to do x to the negative 1, that was a good strategy for anything in the denominator besides just x alone. X squared, that would have been the way to go. X cubed down here would have been the way to go. X to the negative 2, x to the negative 3. For x to the negative 1, you would have tried, you would have gotten x to the 0 over 0. Oh, that's right. It's ln. The good thing is the power rule breaks down and fails for 1 over x. It's a good thing.
If it didn't.
Right? If it didn't, then you would be solving it and be like, oh, I'm right. No, you're not. You're wrong.
Exclamation.
All right, so those were not easy, but they were basic as far as applying the rules, right? If you're thinking about how they could rewrite it, they're not going to really rewrite that one. I mean, I guess they could use some trig properties, but no, that's gross. This one, they're not going to really rewrite them. There's no real way. This one, they could do something like common denominators. They could multiply this guy by 2 over 2, this guy by 4 over 4, and put it all together. Plus C. They could do that. Doesn't mean they will, but they could. So let's go back to some other more interesting ones. I'm going to call this example 5, because the one on the page before from the quick check, we could call this number 4, A, B, C, if you want to do it that way. So it's be number 5 as far as our examples. Number 5 as far as our examples. Now hold on, there's no integral. I know. Why? Because it wants us to, for number 5's direction, I think you guys might have something in homework. It wants us to find the derivative, then make a new, it's probably not all that new, but that's okay. A new for us, integration rule from it. If every integral is just a derivative backwards. And as you guys saw yesterday, all of those integration formulas came from, or rules, came from derivative rules. Technically, they could give us any function and say, hey, derive him, and then be like, hey, look, a new integration formula that goes backwards. How would we derive this guy? Good. Can't forget our deriving skills. Can't forget our deriving skills. Quotient rule. Bottom. D top. Keep going. Bottom D top minus top D bottom all over bottom squared. Equals, I'm going to go kind of quick. That'd be x squared minus 2x squared. I think that'd be negative x squared. Plus 3. All over x squared plus 3. That would be my dy dx. Thank you. How can I make a derivative? How can I make an integration formula rule from that derivative?
Can we just take the derivative, just plop it in?
Plop it in. It's going to be a derivative sandwich, right? Integral says, give me the derivative and I'll pop out the original. So put in the derivative, negative x squared plus 3. We didn't simplify because the signs were different. We couldn't pull out that negative in case you're wondering why we didn't simplify. They don't match. Plop in the derivative, and guess what comes out? The original. Except we didn't know whether or not there was a constant, so if it was an integration rule, we would put the plus c. If we're just given the derivative, we wouldn't know where it came from. Now this might open your eyes a little bit. This might open your eyes just a little bit to a dilemma with integrals. Guys, you found a lot of derivatives last semester. Did they all look the same? when did they start looking really messy?
Mm.
Not power rules, not trig rules. They started looking really messy when you had product rules, and quotient rules, and fractions within fractions that were then complex fractions. Didn't the derivative end up looking sometimes way different than the original?
Yeah.
So in order to even go about solving something like this to get that,
Individual rules for every problem.
you could make individual rules for every possible derivative you've ever found, and then find a whole lot more. And it's called integration tables. And it's a big old book. Dr. T used to have them. A big old book of rule after rule after rule after rule in different kinds of categories with different quotients and different powers and different. And some applied mathematicians, engineers, etc., if they ever needed an integral, would just go looking at that table trying to find the right one. They actually kind of forget the basic skills of how to do easy ones. Some of my BC kids, Dr. Teague was looking in this big table or this big book of integration formulas. He was looking. He's like, I know there's one in here. And they were like, you just solve it like this. And he was like, oh, that works. So there can be hundreds, thousands of integration formulas. So in CalcAB, first of all, we don't learn how to even solve by hand all the different possible algebraic types. We're doing the basics right now. We'll expand that a little bit in future sections, future chapters. But I just want you guys to understand the idea. When you see a division in an integral, there is no quotient rule to go back. There is no quotient rule to go back. So that's re-emphasizing really quickly something like this. If you're seeing it in this section, it's possible, and you need to undo the division and then solve it with your basic rules. Don't make up a rule. If you make up a rule, it's going to be horribly bad. Don't do it. Some of you try to do a derivative to say, integrate the top, integrate the bottom. No, it's not even going to be close to right. Okay? So be careful when you see division. If you see division in this section, either it's one of these that you've made from a derivative, or it's one that you can undo the division. There is no division integral rule. Because derivatives are nasty. Or they can get nasty. Okay, with that. Number 6. In homework, if they give you a function and say take the derivative, what they're saying is plop that in an integral, and all of a sudden you just made one of those formulas that, I don't know, someone somewhere might want to use someday. Because it might end up modeling some sort of phenomenon. Okay, number 6. Make up a rule. No. Rewrite it to fit one of your rules, because it must. It's in this section. What rule could it fit?
X to the X.
Yeah, it could be power rule.
Power rule. I can change any radical to be a power. So it is going to be x to the, it's squared, so 2 is the big number. It's cube rooted, which means, divide by 3. There you go. So you guys tell me what to do.
We're going to bring it down on numbers.
So you do like
So take that 1 over n,
5/3.
1 over n plus 1.
Now, hold on. I could do plus 1, but what's a lot easier in my pen? Plus 3 over 3. Good. I can do my plus c. And then, if you want to, you could add that and say, hey, 2/3 and 3/3 is 5/3. I could do 1 over 5/3, but what's a lot nicer? Yeah. You guys get into the pattern of just finding this and then multiplying by the reciprocal. Life gets a whole lot
We should
nicer.
put 3 first in the
Oh, yeah. Yeah, your brain can do that. That's totally cool. Because you guys got to where derivatives, power rule, you were doing it in your minds, right? Subtract 1. Well, hold down, then subtract 1. For integration, you have to add 1 first, and then divide by, or multiply by the reciprocal. You have to add 1 first, then multiply by the reciprocal of the new power, not the old power, the new power, because that's the one that's coming down. Are we okay? Wait, pause. Making it match. If it started as a radical, how could they rewrite this?
I mean, just
As a
As a radical.
3.
So you have a radical, x to the, good,
cube.
big number, 5th cube rooted. Plus. We just have to know, if we're rewriting to integrate, then they might rewrite to get back to the final answer. Just a heads up. How about this one? Oh, easy, use the product rule for in. There is no such thing. No. No such thing as a product rule for integration.
Same way, there's no such thing as a quotient rule for integration. So how on earth can we rewrite this?
Manually square it out.
Manually square it out by, wait, don't pull a puppy. How do you manually square it?
The thing
Foil.
Yeah, okay, then.
That's foil.
Or you can think, square the first, square the last, double the outer times the inner, or the first times the last.
Yeah.
There is that perfect trinomial, whatever, square shortcut that no one ever really remembers. But it's going to end up being 4, square the first.
Square first.
Outer, inner is going to be these two multiplied. Can you rewrite it again? So 2y squared times 2, so 4y squared.
Oh.
And then square the last.
That makes much more sense. It's easy. It's very easy.
It's easy, but in algebra 1, no one likes that trick.
I don't know why. It's very
And so I just keep on saying, like, hey, rewrite it, foil it, rewrite it, foil it, rewrite it.
Well,
Foil it.
But
you could
can
just-
see it visually. It's easier.
Yeah.
That makes sense.
Because if you know this is the answer, well, how'd you get there? Square him, and then multiply and double.
It's so short.
But it is a lot for like an 8th grader to take in and to memorize.
No.
Can you imagine how well you memorized the quadratic formula back then? How do you integrate? Wait, did you guys realize now we have y's? Is that really a problem?
No.
No. Just do it with y's. Okay, what's the integral for?
4x.
Okay, well, for
y.
what? For those of you needing to look at your tables for the rules, that's the integral of a constant will always be a constant times a variable. Alright, how are we doing?
You're doing alright.
Do we know this is going to be y cubed?
Yeah.
Do we know the 4 is going to be chilling? And do we know to divide by?
3.
Now pause. In your brains, are you already kind of double checking real fast? Bring down the 3, it cancels. 4y squared is the derivative. Aren't we reviewing our derivatives as we check our integrals?
Yes, we are.
Go team. Alright, so then you guys go.
1/5 y is
1/5 y to the 5th or y to the 5 over 5, either one. It's good for us to know they're the same thing. 1/5 y to the 5th is y to the 5 over 5. Same thing.
Let's see.
Let's see. Ooh. What do you think is really easy for people to forget on long answers with integrations?
plus
Let's see.
Guess what's really easy for people to forget on forever quizzes with the integral rules? So I'm going to say probably at the beginning of any forever, sorry, I almost said endeavor, forever, you're an AP, any forever quiz with integral rules, make sure that you see that everything's there when you write down your answer. Now, only for indefinite integrals.
That should have been our shirt and stuff. Make sure you see everything.
Oh, man.
I would have been bothered.
Finding C. Hey! Speaking of which,
I think it's
see what I did there?
Why she pull it?
Finding C. Initial conditions and particular solutions.
Look at that.
That sounds
Sounds like a medicine ad where like you're gonna die.
Oh no, this does not sound good. Like where there's all the extra like warnings on there. Yeah?
Make thoughts of suicide. It's like an allergy medicine, but it says may enhance allergies.
Yeah.
You're like,
Or no, the depression medicines will
Cause
say, yeah, may cause you to get really depressed.
Like mood swings.
Yeah.
But like actually have
It's
that
like
like
trying to
mood
be
swings.
inspired.
they're going so fast, all you hear like these words like stroke and heart attack and death and like, it's like, okay.
Ask your doctors.
Yeah, there you go.
Exactly.
So you're like, wait a minute, but isn't my doctor getting paid by like the anyway?
It's all circle.
Capitalism.
Can solve for the, what's the name of plus C? The constant of integration. That's his name. That's his name. Constant of integration. The constant that comes out of integration, specifically indefinite intervals. We already talked about how the only way to find C is if they give us some sort of point. So then this is an example of that. Initial conditions and particular solutions, meaning if they give us an initial condition, if they give us some sort of x1, y1, doesn't even need to be an initial like when x is 0. It can just be any x paired with any y of the original quantity. Then we can find a particular y equals, I should probably do capital F. I'll put it that way. I'm not putting plus C because we won't have to leave it as C. We'll be able to plug in and we'll be able to solve. We'll be able to get a particular solution, a specific solution, not a general family of solutions. And here's an example. A very basic example, but still it looks a little different than you're used to because, guys, where's the integral?
Oh no.
You integrate both.
Pause!
Let's
Sean,
make our
what did
own.
you say we did with the derivative a second ago to go back?
We make our own rule.
Plop them into?
Plop them in. Make a sandwich.
Yeah, plop them into an integral and say, hey, if I need to get to y from dy dx, right now we'll just go that way. If I need to get to y from dy dx, well that's integration at its core. Given a derivative, go back. Alright, fine, so I'll plop the derivative, I'll plop the f prime into an integral, and what's going to come out is going to be the antiderivative, or the y equals. We'll use the point in just a second. But in case it helps some of you, remember, this is just saying when x is 1, y is 0, right? Y of 1, it's awkward notation, it's like f of 1. When x is 1, y is 0. Okay, kiddos, how am I going to integrate this guy? ln! No.
We got.
We gotta change.
Let's start changing stuff.
Okay, let's rewrite stuff. So what's the stuff that we can rewrite?
Bring it up.
We can't move.
And
We can. I might deal with the cube first for simplicity's sake. What would 2x cubed be? 2x, 2x, 2x?
8x cubed.
And here's why I did that. How would you bring it up? I agree, we can. Who comes up? Yeah, I have x to the negative 3. Is it 8x to the negative 3? No.
Times 1 over 8.
1 over 8.
I know. That's hard. The 1 over 8 is a constant being multiplied by, if you want to think of it this way, we could make it 1 over 8 times 1 over x cubed. We could make it 1/8 times 1 over x cubed. The 1/8 is just a coefficient pulling out. The 1 over x cubed becomes x to the negative 3. If I was to write 8 to the negative 3, it's just going to, well, A, it's wrong, because it would, unless you put parentheses, but even then it's not 8 cubed. We already did the 2 cubed is 8. But then also if I wrote the 8 here, it'd be 8 to the 1, x to the negative 3, and that's totally illegal. So pull that 1/8 out. Pull the coefficient away. Deal with the x to the negative 3 using the rule that you know. You guys already started doing n plus 1 over n plus 1?
Yeah.
With negatives at the beginning, I end up writing it all out, not that you have to. I end up writing it all out because it is very easy to get confused. Negative 3 plus 1 will be x to the negative 2 over negative 2, or times 1 over negative 2. Isn't that going to be negative 1/16?
Yeah.
Double check, you bring down the negative 2, negative becomes a positive, 2 over 16 becomes 1 over 8, x to the negative 3. There we go. However, they didn't write it with negative exponents to begin with, so let me write it the way they probably would, which would be, yeah, negative 1 over 16x squared. And this is y equals. They gave us dy dx. I was able to go back to y from its derivative. Except I'm not done. Because they gave me a
Plug it in.
plug it in. When x is 1, y is 0. Who would C be? When x is 1, C is 0, sorry, y is 0.
Multiply both sides by.
Oh, I would just add. How did that work?
Oh yeah, sorry.
No, you're good. I was just making it simple. So I have negative 1 over 16, add it to the other side. Yeah, C equals 1/16. Plug it in. My particular solution is the antiderivative, negative 1 over x squared, plus the specific constant I know because of the clue. What did I do? I plugged in my equation itself. Did we do lots of examples?
Yes.
Yes. Could we have done more? Well, not too bad. We only missed one, and it was a tricky one.
If we were more time efficient, then yeah.
Integration competition tomorrow. Bring your homework fully attended with questions we got stuck on. Even we'll treat them as little baby quizzes to see if you got it right. Odds check tonight. Bye guys. Commit. Stay committed. Be committed. Work on that homework.
Misty, I haven't been committed since